churro. Okay, so on our property, we've got trees, lots of trees. And in the wintertime, when it rains here, it's wintertime right now, but we've had good weather. We've only had a couple of days of power outage, but in the wintertime when it's bad weather and it rains and then the wind blows, these trees fall and hit power lines, which makes us lose power for a couple of days, sometimes 3 days. But luckily we have a natural gas powered generator, which you will see later. The problem is that we don't want that generator to run all the time. It can, but it costs between like 80 and $100 a day to run the generator. It's a big generator for the whole house, which is great. But you know, we could turn it off and be totally happy like overnight. You know, the food in the fridge would still be okay. It would be fine. But there's no easy way to power it off without going outside in the rain and in the elements. So what I want to do is I want to put in a kill switch for the generator so that I can basically kill it at night and then restart it in the morning. But I don't want it to be outside. I want it to work from a convenient place inside the house, or even ideally, it needs to be electronic because I would like to access it from anywhere, even from our phones. Like if we're traveling, if we're not here and the generator's running, I don't want to necessarily run it all the time. I'd like to command it remotely to turn off and then turn on later. Even possibly even have scenes or schedules where the generator could start and stop, you know, at certain times rather than run, say, all night long. It also needs to be battery backed up because, of course, if the generator turns off and the power is cut to the house, I will have Wi-Fi, I will have cellular for a while because I have battery backups on those things. But if it's, you know, if it's out for a long time, you know, whatever's powering the circuit that's listening for the generator to come back on, whatever circuit I put in, you know, I don't want it to totally go offline where I lose access to it completely because there's no power. So it needs to be battery backed up too. So again, design goals for this generator kill switch. It needs to be not outside, ideally electronic, so it can be controlled from a phone or an iPad. It should work anywhere in the world, not just inside the house. And it needs to be battery backed up and last for several days in case I want to turn off the generator for a while and turn it back on later. And as a bonus, it would be nice for it to have scenes or schedules so that I can program the generator to say only run between the hours of 8 and 5, and then, you know, maybe turn it off, you know, at nighttime because everything will be fine. The fridge will be fine for a few hours. Anyway, those are the goals. So I'll talk about how I'm going to try to achieve that. So this is our 20 kW generator. And if we wanted to turn it off, I would have to come out here, say in the rain, and hit this off button so that it would no longer run. There's no way to turn off the generator from inside the house. Even inside the garage, there's a transfer switch that monitors the electricity that's coming in from the utility and determines if it needs to switch to generator power. But even from this box, which would still be, you know, inside, not in the elements, not in the rain, I still can't turn it off from here. So the solution I have in mind is this. I'm going to put this box in the closet next to the transfer switch, and it's going to have a battery backup. It's going to have its own power supply. This is AC, and this will be converted to DC, and also charge the battery with this supply. And then also in this box will be this. This is a small unit which has a connectivity via Z-Wave, and I will be able to remotely command this relay to fire via Z-Wave through our alarm system panel. Okay, so I've got the box sort of assembled here. I've got the power supply connected to a 12-volt battery, and I've got the Z-Wave device, the relay, connected here, just sitting in here with some Velcro. and it's connected to the 12-volt supply, which is powered off the battery. I don't have the, this box is somewhat portable right now. I don't have it connected to an actual power supply yet. So a wall power supply, that is. The Z-Wave device is blinking blue, which means it should be discoverable by the alarm controller. So let's see if that's the case. Okay, so I've come over here to the alarm panel. I'm going to click on devices. I'm going to click on Z-Wave setup. And then I'm going to say add device. And it says start add device, press function key on device. So I will come over here. And the Z-Wave device is in setup mode because it's blinking blue, but I think if I press this button on the back, it should be recognized on the network. So let's try that. This is the button. Okay, the light turns solid blue on the top there. If I come over here, okay, I've got the device added to the Z-Wave network now. I'll spare you the video of me finagling with the button on the device, trying to add it and hold the camera at the same time. But you'll see here, if you go to devices and then scroll all the way down, there's a new device down here called binary switch. So looking back at our setup here, I've got the relay output connected to these yellow and green wires. And I have a multimeter here that will beep when the relay is closed, or in other words, when there's continuity. You'll see here, when the wires are crossed, it'll beep. So when I command the relay to close over the Z-Wave network wirelessly, you should hear the meter beep. So let's go back here to the controller. Okay, so to demonstrate this, I can come back to devices, scroll down to the binary switch, and when I click this, it should command the switch to close, which will close the relay, and you'll hear the continuity on the meter. So there you are. The meter is beeping because the circuit is closed. And I should be able to do the same thing to open the circuit. And there you go, it works. So now that this is working, those yellow and green wires, I can connect to essentially the generator start circuit. And when those wires close with the relay wirelessly, the generator will be enabled when the transfer switch commands it to start. And when it breaks that connection, doesn't matter what the transfer switch says to the generator, the connection will be broken, so the generator will be in disabled or non-running mode. Okay, so before I end this video, in the next video, I will show how I'm connecting this device and mounting it in the closet next to the generator transfer switch so that green and yellow wire circuit can be connected to the transfer switch and interrupt the generator, enabling it or disabling it when it's commanded to run when the electricity goes off. Anyway, what I also wanted to show is one of the design goals here, where we talked about how I wanted to be able to control this generator kill switch remotely. So I'm showing an iPad here connected over Wi-Fi. It could be over cellular as well, with this app called the Total Connect app. And that's an app that comes from Honeywell and allows you to control the panel remotely. Again, either over Wi-Fi or cellular. I'm doing Wi-Fi because this is from the iPad. And once you sign into the app, you can do things like enable or disable the alarm, clear faults, etc. But you can also control devices on the network, just like you can from the panel on the wall. And so you see here, binary switches here. And if I click that to turn it on, it'll take just a moment to send the command. But you see here that now the circuit has been tripped wirelessly from the iPad, and you can see that I can also turn it back off as well. So again, in the next video, we will show the new unit installed and connected to the transfer switch.